Hello guys, I'm audible. Oh, that's great. How's everyone doing? How's everyone doing? Good. Okay. Happy New Year to all of you. I hope all of us have a great 2021. Uh, all the best for this year. Guys, have we met before? I guess we have, right? We would have met in the introductory week. I would have taken a class or two in the introductory week. Cool. Yeah, the HLD class. Today we are going to discuss some DS algo. We are going to discuss bit manipulation today. I will introduce the topic, solve some interesting questions with all of you. Before that, let me just very quickly make a comment on the group so that people can join in, right? If there is somebody who's waiting for me to join, they can just very quickly join in. Cool. So yeah, that's great. Just allow me a minute to share my screen and let me know once my screen is visible. Guys, is my screen visible? Is my screen visible to all of you? That's great. Cool. So the topic for today is bit manipulation. And let's see how important this topic is and how you can solve questions that seem very, very difficult on the outset, but how we can utilize them to solve our problems. Okay. The first thing that I would want you guys to appreciate before I start the class, does everybody in the class understand what bits are? What is a bit? A bit is basically a number which can either be a 0 or a 1. Is that correct? Bit is basically the building block of any binary number. Bit can essentially be either 0 or it can be 1. Okay. Does everybody in the class also appreciate that all the data that is stored in a computer is essentially stored in the form of bits? Can everybody appreciate that? So yes, everybody knows that every data that is stored in the computer is essentially stored as bits. It can be either 0 or 1. We call 1 as a set bit and we call 0 as a unset bit. And why does computer use, let's say, binary number system? Because it's easier to maintain two states, high or low, and that you can correspond the high state to a set bit and the low voltage state to a unset bit. Guys, is that clear? I hope that's clear to everybody. Cool. Now, okay, we know what bits are, we know what set bits are, we know what unset bits are. Let's now go and discuss some logical operators that a lot of you would have heard about, right? Logical operators. What are logical operators? Have you heard about the logical operator AND? Has everybody heard about the logical operator AND? AND is an operator which takes two inputs, and these two inputs are both Boolean inputs. Is that correct, guys? AND will take Boolean inputs, and essentially if you have a true and a true, it will give you a true. Apart from it, if you have any other combination, that is true and false, or false and true, or false and false, you will always get a false. Guys, is that clear? This is what a logical AND is, right? But keep in mind, a logical AND takes two Boolean values. Is everybody with me? A logical AND takes two Boolean operators. Now, if you want to, let's say, use this logical AND in your programming language, if you use it with Boolean operators, that's great. But some programming languages also allow you to use it with integers. For example, if you do 7, let's say, and 5, right? What will it return? This is being the logical operator. It will just assume that this is a number, this is a number. It will assume a number other than 0 as true and only the number 0 as false. So this logical operator will treat both 7 and 5 as 1, and your answer will be 1, or the answer will be true. Guys, is everybody with me? Is everybody with me? I have just defined, taking a minute, what logical operators are. One operator, which is AND operator, I've just defined. Similarly, you can understand what a OR operator is and other operators. But these are logical operators where your input needs to be a Boolean input. If you give an integral input, it will try to see if the number is 0, it will assume it to be false. If the number is anything but a 0, it will assume it to be a true and solve your problem. This is very simple, logical operators, but they don't give you a lot of power in solving questions because they just assume every integer other than 0 to be positive, to be true. Now, there is another concept which is what we are going to base our class on, and that is called as bitwise operators. Okay, this is the concept that we are essentially going to base our class on. What are bitwise operations? You can have same operators that you had before in logical operators. So let's start with the AND operator. But this time around, this AND is a bitwise AND. And in most programming languages, you will write it as a single ampersand. Bitwise operator gives you the answer by doing that operation bit by bit. Okay. So if I take the same example, I say that I wanted to do 7 and bitwise 5. What will I essentially do? Let's assume 7 is represented in its binary format. What will that be? That will be, so this is 2, this is 4. 7 will essentially have 4 plus 2 plus 1. 7 essentially will be 111. Is everybody with me? 7 will be 111. Similarly, 5 will be 4 plus 1. So it should be 101. Okay. 7 and 5. If I want to do bitwise AND, what will I do? I will essentially apply this operator bit by bit. So let's start with any of the bits. Let's start with the least significant bit, 1 and 1. So a 1 and a 1 will give you 1. 1 and 0 will give you 0. And 1 and 1 will give you 5. So the answer for 7 and bitwise AND 5 is essentially going to be 5. How many of you understand this, guys? How many of you understand this? I want all of you to reply. The distinction between logical operators and bitwise operators. In today's class, we are going to utilize bitwise operators to solve so many interesting problems and see how easily we can solve them. There is one no. Let me repeat this once again in today's class. Just doing a thumbs down does not give me information of who is doing that thumbs down. I have requested this feature change. We'll get this done very soon. But now if there is anybody who in the class who did not understand it, please write a no in the chat so that I can know who you are. I can unmute you and have a discussion. Okay. So I have one thumbs down. Whosoever you are, if you have any doubt, please let me know. I will unmute you and have a discussion. Okay. So if anybody has any doubt, please let me know. We'll unmute. We'll have a discussion. Cool. So we have just discussed this. I'm waiting for if somebody wants to be unmuted, let me know. This is bitwise AND. Let me define a few more bitwise operators. Let's look at bitwise OR. Okay. So if I take the same problem, I want to do 7 bitwise 5. I want to do 7 or 5, where OR is the bitwise OR. I will represent my 7 as 111, my 5 as 101. If I do the OR, I will essentially get 1 or 1 is 1. 1 or 0 is what, guys? 1 or 0 is what? It's 1. 1 or 1 is 1. So essentially you get your answer as 7. Okay. Or basically just looks for at least one set bit and looks for both set bits. Okay. So this was the second operator, bitwise operator. Or let's look at the third bitwise operator, which a lot of us will eventually start liking a lot more because that gives you a lot more power. That operator is called as a XOR. What is XOR? XOR basically means exclusive OR. Okay. And was saying that, hey man, both of you need to be set before I can give you a set answer. Or says any one of you need to be set before I can give you a set answer. XOR says exactly one of you need to be set before I can give you a set answer. Guys, is that clear? So what will XOR do? If you have both the bits as set, it will give you a 0. If you have both the bits as unset, it will give you 0. If you have any one of the bits as set, and that is exactly one of the bits set, only then it will give you a true. Is everybody with me? Is everybody with me? Cool. I hope we have understood all the fundamentals that we wanted to know. Before we move ahead, let's spend a few minutes trying to understand this XOR even more. Okay, so let me write a few properties of XOR, and you guys tell me whether that is making sense or not. Okay, properties of XOR. Just a disclaimer. Some of you may be feeling, hey man, this seems to be very, very theoretical. This will only last for another 5 minutes. Trust me. Okay. Even though this is very theoretical, but it is very, very important for me to get this straight before I can jump into some interesting questions. But for now, your sole agenda should be to understand this fundamentally very, very well, and then apply this later in the questions as we are going to move along. Okay, cool. Properties of XOR. XOR essentially says that, hey man, exactly one bit needs to be true. Okay. Before I move to properties of XOR, let me try to do XOR of 7 and 5. 7 was 111. 5 was 101. What will XOR be, guys? The least significant bit will be a 0 because both of them were set. The second least significant bit will be 1 because exactly one of them was set. The third one will be 0. Your answer comes out to be 2. So XOR looks for exclusivity. XOR looks for exclusivity. Now I have a question for you. Do you think if you XOR any number with 0, what should I get? Can you intuitively figure that out? You should get that number itself. Isn't that correct? Because if you XOR a number with a 0, 0 never gives you a 1. So it will allow your number to express itself completely in the XOR. How many of you understand this? Because 0 always gives you a 0. If your number had a set bit, it will be expressed in the answer. If the number had an unset bit, it will be expressed in the answer. So A XOR 0 is 0. Now, Saurav says A not equal to 0. Saurav, even if A was equal to 0, what would your answer be? 0 XOR 0 essentially is what? It's 0. So even when A was 0, you can still define this property. Saurav, does that make sense? It makes sense, right? So A XOR 0 is always A. Let's look at some more interesting properties of XOR. Okay. A XOR A. What will this number be, guys? What will this number be? This will be 0. Why? Because XOR looks for exclusivity. If you XOR the same number with itself, nothing remains exclusive. Is everybody able to appreciate that? All the bits get repeated. Nothing remains exclusive. Your answer essentially boils down to 0 now. Okay. Now, let's look at some more properties. If I do A XOR B, is that wise to say that that will be equal to B XOR A? Of course, yes. Order does not really matter. The only thing that matters is exclusivity. The exclusive one could have been in the first number or in the second number. That does not really matter. I can always switch A and B and get still the same answer. Let's look at another property. A XOR B XOR A. What should this number be, guys? So I first XORed A and B. Then I XORed B with A. Do you understand that in the overall process, these A's will cancel out each other and you will essentially be left with a B? Because A's will remove their exclusivity because I had it twice. How many of you understand this, guys? How many of you understand this? This is very, very interesting. Intuitively, you can understand A will cancel out its own exclusivity because I have two A's. Mathematically, you can prove this by using the third property. You can say A XOR B XOR A can be represented as A XOR A XOR B because B XOR A could have been represented as A XOR B. And now you can use this property which tells you A XOR A is 0 and you will say 0 XOR B. And then you can use this property which will tell you the answer as B. Guys, isn't this interesting? Intuitively, we knew the answer, right? It's B. But I've just used the first three properties to prove that A XOR B XOR A will always be B. Will everybody remember this always? Will everybody remember this always? Everybody will, right? Can we extend this property? So I have written this fourth property, but can we extend this? Yes, I will make a claim we can. All the numbers that get XORed even number of times will lose their exclusivity and contribute a 0. How many of you agree to this statement? All the numbers that get XORed even number of times will lose their exclusivity and you will only get a 0 contribution for them. And what does a 0 contribution in XOR do? Does nothing, because it does not provide or destroy any exclusivity. How many of you understand this? A 0 contribution in XOR does not provide any exclusivity or does not destroy any exclusivity. So 0 contribution means as good as no contribution at all. So if I just use that property and give you a number like this, will you be able to tell me what the answer will be, guys? A was being XORed 3 times, so 1 A will remain. B was being XORed 4 times, no B will remain. C was being XORed 2 times, no C will be remaining. So your answer will be A XOR 0 XOR 0, which is nothing but A. Is everybody with me? We have represented our fourth property as well. Now, let's try to write down the last property and then we move on to some interesting questions. The last property here is, let's say I tell you two numbers, when you XOR them, you get a K. Okay. So if I XOR A and B, I get K, which represents the exclusive set bits in A and B. Isn't that correct, guys? K represents the exclusive set bits in A and B. This will essentially imply that your A will be K XOR B and your B will be K XOR A. How many of you can understand this? If I am saying A XOR B is K, that is two numbers when XORed together give you an exclusive number as K. Now if I want to get the first number, that is A number, I can just get a XOR with K and B to get A. Similarly, I can just do a XOR with K and A to get B. Is everybody with me? Is everybody with me? So I will just prove this mathematically. Intuitively, this will make sense. But to prove this mathematically, it's again a very simple operation. You had A XOR B equal to K. I have a question to you guys. If two numbers are equal and I XOR them with the same number, will the answer still remain equal? Let me rephrase the question. If two numbers are equal, you just apply the same number XOR onto both the sides, the answer will still remain the same, right? So if I can just apply a XOR on both the sides, my equality should still hold, right? And now when I look at A XOR A, this means a 0 contribution, which only leaves B on the left hand side, which essentially means B is nothing but A XOR K. Guys, is everybody with me? So I've just mathematically also proven that yes, this definition also holds. So we have discussed a lot of interesting properties about XOR. The only way to understand XOR is by looking at this definition. If you always remember this definition, that exclusive OR, that it is trying to find out the exclusive set bits, or it is wanting you to have exactly one set bit, it will give you a powerful understanding that you can apply in lots and lots of questions. Okay. Now, before I jump into the questions, I will just define two more operations and then we jump into some interesting questions. So we have discussed AND, OR, XOR. Let me discuss logical left shift and then we will discuss logical right shift. Okay. So let's just look at that. Logical left shift. Okay. So first of all, in languages like C++, how is it represented? It is represented by two signs pointing towards the left, right? So you are doing logical left shift. Now, what does that mean? Let's look at any number. Let's look at A. If A was essentially a 1, this can be represented as 1 and some leading zeros. Is that correct, guys? Is that correct? 1 can be represented as some leading zeros with the last significant digit as 1. How many leading zeros? How many of you appreciate that the number of leading zeros will be determined by what data type you are storing it in? So it can have infinite leading zeros. If your data type only has 4 bits, it will have 3 leading zeros. If it had 8 bits, it will have 7 leading zeros. If it had 16 bits, it will have 15 leading zeros, and so on and so forth. For now, let's assume my number was a 4-bit number. Is everybody with me? Now, what does left shift do? If I say A left shift with 1, it means that all the bits should be shifted towards the left by 1. What does that mean? That your answer, that is your A left shifted by 1, should look something like this. This bit gets shifted to the left, but there is no bit to move to, so this gets dropped. This 0 comes here, this 0 comes here, and this 1 comes here. So what does it look like? A 0, then a 0, but then a 1, and the last bit which get now added will be added with a 0. How many of you understand this, guys? How many of you understand this? So if I do A left shift 1, I will essentially move all the bits towards one side on the left. If I do A left shift 2, do you appreciate my number will look something like 0, 1, 0, 0? Does everybody appreciate this? Does everybody appreciate this? Everybody does. Let's say I do A left shift by 3. Do you understand my number will look something like 1, 0, 0, 1, 0, 0 basically? So let's look at it even more closely. My A originally was 1. I left shifted my A with 1 bit. My A becomes now what? 2. Isn't that correct? My number on single left shift becomes 2. My number on 2 left shifts becomes 4. My number on 3 left shifts becomes 8. Now if I do another left shift, what will my number become, guys? If I do another left shift, Anchit says it becomes 16. Anchit, do you realize that there are only 4 bits here? If there are only 4 bits here, this number becomes 0. Right? If there were more than 4 bits, this number will become 16. How many of you understand this, guys? So this left shift operator is dependent on the number of bits that you have. Will you always remember this in your life, guys? I have seen so many people forgetting this and making mistakes. Will you always remember this, guys? That left shift bit operator's result depends on the number of bits that you have. So the moment this will become 0, now no matter how many times you keep on left shifting it, it will always remain 0. Isn't that correct? Okay, cool. So now let me make a very interesting comment and you guys will tell me whether that comment is correct or not. The left shift bit operator will double your number on every left shift till the time your most significant bit is not 1. How many of you understand this? Your numbers will keep on getting doubling till the time your most significant bit is not 1. The moment your most significant bit is 1 and you left shift it again, your number will lose a big chunk of it on left shifts. How many of you understand this, guys? How many of you understand this? So your number will always become twice its size on left shifts until and unless your most significant bit is 1. I hope everybody will remember this. Do I need to write this? Do I need to write this or will you always remember this, guys? I hope you will remember this. So I will skip writing. If you wanted to write it, just let me know. I will write also. Cool. So we have just discussed logical left shift. Now there is another corresponding operation that is called as logical right shift. And let's try to wrap our heads around right shift as well. First of all, what's the symbol? The symbol is this. How about a signed bit? Kriday, I will not discuss signed bits today. You will just have to read about it, but just try to understand what can happen fundamentally, right? Let's just try to understand what can happen fundamentally. Signed bits are essentially you use the bit on the left of the most significant bit as the signed bit. Kriday, isn't that correct? You use the bit at the on the left of the most significant bit as the signed bit. So if you include that bit also in your left shift operator, your sign may get lost. Hriday, is that correct? Your sign may get lost. On the other hand, if you don't use that most significant bit, the signed bit in your left shift operators, then your sign will remain the same and everything else happens the way that it was supposed to. Hriday, does it make sense? So now you will just have to figure out what language does what, but you have understood that from a fundamental point of view, what two options could have been there. I hope you understand that, Hriday. I hope you do. Now let's just discuss logical right shift, and that would be it. Milind, we don't need to discuss any more operators. These are our powerful operators that allow us to solve so many questions. So don't worry about anything else. Milind, does it make sense? I hope it does. If you have any question, you can reach out to me. I can get on a chat with you and solve whatever questions you have. Cool. Now let's come to logical right shift. Logical right shift does exactly the opposite of what logical left shift does. So let's just take a number. Let's start with a number as 9. Okay. Or let's for now start with number 8. I will just tell you what happens if you start with 9. 8 is represented as 1 and 3 zeros. I hope everybody appreciates this. Now, if I do 8 right shift 1, I should essentially get every bit moved 1 towards the right. The most significant bit now being a 0. Your number will look something like this. Isn't that correct, guys? Your number has now become 4. It has halved. Then you do another right shift, let's say. Then your number becomes 2 because you have dropped another bit on the right. Then if you do it thrice, then what does your number become, guys? It becomes a 1. If you do it 4 times, your number now becomes a 0 and it remains a 0 forever from there on. Is that correct, guys? Does everybody in the class appreciate what a right shift will do? So I hope you will appreciate. Till the time you have the least significant bit as 1, your numbers will keep on getting halved. How many of you will remember this? Just like in the left shift bit, I said till the time your most significant bit is 1, it will keep on getting doubling. I will just repeat that statement here and say till the time your least significant bit is not 1, it will keep on getting halved. Will everybody remember this? So you saw it will keep on getting halved till your least significant bit is not 1. Cool. So we have discussed this as well. It should be interesting for all of you. Now let's jump into our questions, and I will add my first bookmark for today's class, and then I will keep on adding bookmarks as and when we keep on discussing new questions. For now, let me just add a bookmark here. Let's check if the ith bit is set. Okay, cool. So let's look at the first question, which is a very simple question. Let's look at how will we solve that. Question says, you are given a number n. You want to check if the ith bit from the right, or you can call it the ith least significant bit, is a set bit or not. How many of you got the question? You just need to check if the ith bit is a set bit or not. Ith bit from the right is a set bit or not. So let me give you an example. Let's say the number that you had. Guys, give me any number, a smaller number, or let me give you a number. You tell me what is that number in binary, in decimal representation, because that will also allow me, Ankit, you are absolutely right. That will also allow me to figure out how quick you are in figuring out how to convert binary to decimal. Can you guys convert this to decimal? Milind says 12. What about others? Nobody else? Hey guys, are you with me? Shadab says 92. Keshav says 102. Shashi says 1010. Shashi, that's good. Anchit says 102. Anybody else? Okay. So let me just very quickly tell you how do we do that. This is 2 power 0, which is 1. You got it. Got it. So this was 2 power 0. 2 power 0 multiplied by 0, which will contribute 0. This 2 power 1 multiplied by 1, which will contribute 2. Well, my pen is not working. So this will be 2. This will be 4. This will again contribute 0. This will contribute 0. This will contribute 32. This will contribute 64. This will contribute 0. Does everybody understand what I just did here? 64 plus 32 will give me 96. 96 plus 4 will give me 100. 100 plus 2 will give me 102. My answer comes out to be 102. So if the number that you were given was 102, okay, now you want to figure out the sixth bit from the right. So somebody says that tell me whether the sixth bit from the right is a set bit or not. This is the sixth bit, right? How can you figure out whether this bit is a set bit or not? Can you guys answer that? Right. Right. So a lot of you are giving correct answers. I will just maybe tell you the way we should look at it, and then we'll always get the answer. Okay. So thank you for a lot of your answers. A lot of you are actually correct. How many of you have no idea how to do this? Anybody in the class who has no idea how to do this? Anybody in the class who has no idea whatsoever how to do this? Everybody has some idea? That's great. That's great. So now just try to appreciate. If I want this bit, figure out what this bit is, do you think that if I just AND this n with a strange number which only has 1 at this bit and zeros at every other bit, do you think my answer, because AND is a must have, AND says both of my options should be 1, if my number, the answer that I get can either be a 0 or the answer that I get will either be 32. How many of you understand this, guys? If I AND my answer, if I AND my number with 32, or in other words, a number which only has this bit as set, there are two options that I could have got. Either my input had a 0 here. If my input had a 0 here, that bit will also become a 0 and your answer becomes a 0. Is everybody with me till this point in time? On the other hand, if that bit was a 1, then your answer essentially remains this because everything was 0. So your answer will either come out to be 31, 32 or 0. If it comes out to be 32, you say that my bit was a set bit. If your answer comes out to be 0, you say my bit was an unset bit. Is everybody with me? So how did you figure out this 32? So if somebody wants to figure out the sixth bit from the right, you will just do 2 power 6 minus 1, which gives you 2 power 5, which is nothing but 32. Guys, isn't that correct? Isn't that correct? So what will you do? How will you solve this question? You will take your n, you will write a bitwise and then you will say 2 power k minus 1. This will give you your answer. Another way to do this is by using some shift operators. Let me tell you how we can use shift operators. Having a 1 here, how many of you understand that if you started with a 1, if you started with a 1 and left shifted your 1 5 times, your number 5 times, you would have moved this 1 from here to here. How many of you understand this, guys? That you could have taken a number 1, shifted that 5 times and then did a AND. So this is one possible way. The other possible way is n and 1 left shifted k times. Guys, isn't that correct? How many of you understand this is correct? How many of you think this is wrong? This is correct, right? Sorry, not k times, but k minus 1 times. I'm sorry. K minus 1 times. Right? So this is another way of solving the same problem. Is everybody with me? Is everybody with me? Right. Cool. That's great. Can you explain again? Saurav, can I unmute you, man? Can I unmute you, have a discussion, and then explain to you? Yeah, that's great. Let me unmute you, Saurav. Hey, Saurav.
Yeah, hello. Hello. Yeah.
Hi, man. How are you?
Yeah, I'm fine.
Oh, that's great. Cool. Let's discuss this question, right? You want to figure out whether the kth bit from the right is a set bit or not, right?
Yeah.
You appreciate that a AND operator may come in handy here, because AND forces you to have a bit, all bits set at that particular bit, right? So if I want to figure out the kth bit from the right, why shouldn't I take a number which only has a 1 at the kth bit at the right? Every other number is a 0. If I add the two numbers, I will get either a 0 because your original number did not have a 1 at that particular bit, or I will get the second number itself because your original number had a set bit at that particular bit, right? So these are the two options that you have. If you have the first option where you get a 0, it essentially means your original number had an unset bit at that bit. Or if you get the number itself, you essentially understand that it was a set bit. Is this clear?
Yeah, this part is clear, that left shift part.
Right. So now let's just, before I move on to the second option, let's try to appreciate that 2 power k minus 1. How will you do it? One way to get 2 power k minus 1 is multiply 2 with 2 k minus 1 times. Isn't that correct? You keep on multiplying another 2, another 2, another 2. You do this k minus 1 times, you get your answer. That will take order k time. Isn't that correct? If I wanted to compute 2 power k minus 1, that way it will take order k times. In the maths lecture, Anshuman would have discussed that you can do this in log k time as well. Did Anshuman discuss that?
Log k time? No, I don't.
Okay, he did not. Okay, forget about it. Let's think about it this way. If you have a number 2 power 1, right? If you do a power of it, you make it 2 power 2 in one operation. Isn't that correct?
Yeah.
Now, if you just take another power of this, only in 2 operations, you have raised this to the power of 4. Isn't that correct?
Yeah.
Then if you just do another 2, in only 3 operations, you have raised it to the power 8. So what do I mean to say? That you can raise it to the power k only in log k operations. How many of you understand this, guys? If I could have just kept on doing power of a power, log k times, I will get to my 2 power k in log k amount of time. Sort of, does it make sense to you now?
Yeah, got it.
Right? So everybody in the class, I hope you appreciate that I could have either done this 2 power k minus 1 in order k time, or I would have done that in log k time. If I do that in order k time, that's a bad solution. If I do that in order log k time, that's great solution. But we can forget about the second approach that I just told you to do that in log k operation, and only assume that we only know the left shift operator. The left shift operator is a wonderful operator that allows you to raise a number to keep on multiplying the number by 2. Do you remember that, guys? Just before this question, I told you that the logical left shift operator will keep on multiplying your number with 2 till the time you don't have a 1 at the most significant bit.
Yeah.
Do you appreciate if I started my number with a 1, right? If I started my number with a 1, will I ever have 1 at the most significant bit? I will never have 1 at the most significant bit because my number itself was 1. How many of you understand this, guys? In C++, let's say our integer will take 32 bits. So all your bits will be 0, only the last bit will be 1. Now, if I left shift my number k minus 1 times, do you appreciate that is essentially the same as saying that only the kth bit was 1, every other bit was 0? Saurabh, do you appreciate that?
Yeah, but it won't be equal to 1, right?
It will no longer be equal to 1.
Yeah, yeah, it will.
That you had a n. I wanted to AND this n with 2 power k minus 1. That is correct, right? We know this.
Yeah.
Saurabh, that's correct. Now I think that rather than computing this yourself, first of all, to compute this yourself, you had two ways. One way could have taken you order k time. The other way could have taken you order log k time. Is that also correct, Saurabh?
Yeah, yeah.
Of course, if you have a log k approach, you will not want to take the order k approach, right? So you would always want to take the log k approach. That's great. But we can essentially arrive at this number by doing left shift operators as well. Because if I start my B as a 1 and I keep on left shifting this k minus 1 times, my number will essentially become exactly what I was looking for.
Okay, yeah, got it. No.
So you forget about the good approach of log k time. You just do it yourself, and you essentially then, after you have, so what your answer will become? N and 1 left shifted k minus 1 times.
Yeah.
This is essentially nothing but same as this. Okay?
Yeah, got it.
Now, the only thing that is remaining to be seen here is how much time will this take? Okay? Do you appreciate that this will essentially take me how much time, guys? If I want to left shift k minus 1 times?
Order of k.
It will take me order of k time. If I want to left shift this k times. But do you appreciate I could have done this in constant amount of time as well? Because there are only 32 bits, right? I could have just removed the first k bits, right? Because on every left shift, I essentially drop 1 bit, right? I would have just removed the first k bits and brought my number from here to here and added zeros on the right. Do you understand this?
Yeah.
Can your compiler do this operation in constant amount of time? It can do that, right? Because it knows what all bits to be dropped, what all bits to be added, what all bits to be moved. So this will only take you 32 units of time, which is nothing but a constant amount of time, and you can solve this question in constant amount of time.
Okay. So this will be handled by the compiler itself internally.
This will be, you just tell the compiler that, hey man, I want to do it left shift k minus 1 times. Okay. Your compiler will do it for you, and you are saving yourself with the worry of कि भाई मेरे को तो बहुत time लगा था power निकालने में.
Okay, got it. Yeah.
Thank you, Saurabh. Does everybody in the class appreciate this? Does everybody in the class appreciate this? Right. Now, I have a beautiful question for a lot of you to appreciate. And you will tell me, your answer will tell me whether you got it the right way or not. Okay. First of all, I hope this is clear to everybody. Now, my question is as follows. Does it look to you that I had 3 approaches of solving the problem? The first 2 approaches had you to calculate this number. One was to take order k time. The other was to take order log k time. And now the third approach is a bit shift operator, which seems to take order 1 approach. Is this clear to everybody? I had 3 possible ways of solving this question. Order k, order log k, order 1. This is a bad solution. We all know it will take order k time. Now my question to a lot of you is, do you think this second approach is worse than the third approach? How many of you think second is worse than the third? Please say yes. How many of you say second and third are equally bad or equally good? Please say no. So how many of you feel that second was bad then? So which one is order 1? Adil, do you understand that I have just explained that left shifting is basically order 1? Adil, do you understand that? If you want to left shift, yeah, you understand. So now a lot of you are saying that, hey man, my second approach is bad and my third approach is good. Isn't that what you're saying, guys? You are saying that. Cool. Now let me break that bubble and tell you that there is no free lunch in this world, right? How many? Okay, so first of all, how many of you have heard this phrase that there is no free lunch in this world? We have heard this, right? So there is no free lunch in this world. Now, keeping that statement in mind, let's try to appreciate that. Don't you think your bit shift is doing something similar what you were trying to do by raising power to a power? Raising power to a power essentially means that you are raising power to a power essentially means that you are essentially multiplying your number by 2 every time. How many of you appreciate this? Some of you do. Okay. Raising power to a power basically means that you are taking a number, multiplying the number itself with the number, right? So it will take log k time. That's a great thing. Here I have said that it will only take me constant amount of time, but the units of time that it will take me will be 32 if my integer value was of being set in a representation of 32 bits. Isn't that correct, guys? My question to you is, if I essentially had 32 bits, right, what is the biggest number that I could have stored? The biggest number that I could have stored would be 2 power 32, right? So if I wanted to solve this problem for the biggest number, in the second approach, I would have taken log k time, which would essentially be order log of 2 power 32. How many of you understand this, guys? Even if you were trying to solve this for the biggest number possible, it will take you log 2 power 32 base 2. What will this number be? This number will be nothing but 32. Does that make sense to everybody? So yes, here it seems that it's a log, but here it seems it's a constant, but the amount of time they should take should essentially be similar. Does that thing make sense to everybody? So if there were 32 units that were being computed here because of left shift, I could, even if I have used the log way, it will essentially take me the same number of units. How many of you understand this? Even if you don't, that's not a thing to worry. You can come back to this part of the video, try to listen it again and understand it. But if you guys appreciate it, that's great. So we now know how do we solve this problem. The problem being, you need to tell me whether the ith bit is a set bit or not. Is everybody with me in the class? Can I move ahead to the next question? That's great. Anybody in the class who is getting bored? Anybody who feels कि यार ये क्या पढ़ा रहे हो यार, मजा नहीं आ रहा? Anybody in the class who is feeling bored? I hope not. Cool. So let's now move to the second question. The second question is the following. Abhi, in this question, Milind has raised his hand. Let me unmute Milind, and then I will move on to the next question. Hey, Milind.
Hello.
Himanshu has also raised his hand. Let me unmute Himanshu as well. Yeah, hi, Milind.
Hi, Tarun.
Yeah. You wanted to ask a question? No?
Yes, I had a question regarding that constant time complexity and that log k time complexity. Can you move to that part, please? Yeah, sure. So when we say we want to compute 2 raised to power 32, right? So essentially there are only, the k value would be 31. Okay, so then log k will be 5, around 5, let's say it will be 5. Right, so it will be order, so it will still take 5 steps for us. But when we do this bit shift operation, so it only removes the front 31 bits. The compiler just removes the front 31 bits and makes it 1 at the end, right?
Not the first 30 bits. I'm not changing my end. I took another number 1 and I shifted it k minus 1 times. So I will.
Yeah, so the compiler shifts it 31, I mean removes the 31 bits on its right.
No, it
on
will,
its left, sorry.
It will remove. Yeah. So it will remove k minus one. It will remove k bits. K minus one bits on its left,
Yeah.
and will add k minus bits at the end, and will move every bit in between k minus one bits towards the left, right?
Yeah.
Right. It
No,
will do.
so but it will only take still it will take constant amount of time, right?
Right. So now you try to appreciate it, Milind. Here, when I say constant amount of time, it essentially means moving these 32 bits either or other, right? So when you move these 32 bits, it is constant amount of time. I understand that. It will not depend on the input that you have, but it will still depend on the kind of storage that you have. Isn't that correct, Milind? If you are storing your number in 32 bits,
Yeah.
it takes some multiple of 32 operations. Isn't that correct?
Yes.
If you are storing this in 64 bits, it will take some multiples of 64 operations. That is constant time. I agree. That is constant time. But it will take some operations of the order of 32 or 64, depending on how you are storing a number. That's right. That's
Yeah.
right. Right. So it will take some order of 32 or 64 to solve this. Now I am saying if your numbers were fitted in a 32 sized bit array,
Okay.
that means the maximum number that you could have stored would have been 2 power 32. Is that correct?
Correct.
I am saying even for that maximum number, if you were doing this log wise power operation, it will take you log 2 power 32. And if you solve this, this will give you a number 32. So I am saying even for the biggest number possible, even if you wanted to look at the most significant bit at the 32th index, right? That is the worst that you could have done. Even then, it will only take 32 operations. This does not seem to be constant because it has a factor of log, but I am telling you that even at the worst case, it will take similar number of operations as your bit shift would have taken. Then does it make sense now? Okay. Does it make sense? So does it make sense to log 32 base 2 will essentially give you 32?
No, but to compute this 2 raised to power 32, we only need log 32 operations, right?
Okay, that's right. So you only need log 32 operations. That's right.
Yeah.
That's in fact even a smaller number, right? Even a smaller. So what I'm trying to say is, you should not make a claim that hey man, my log wala operation is going to take lot more time,
Okay.
and will not be getting submitted if my bit shift was getting submitted.
Okay.
That makes sense, right?
Yeah. Got it.
That's
Okay.
it. Cute. Thank you, Milind. Now, guys, let's move on to the second question. Himanshu says that he raised his hand by mistake. So that's fine. Let's look at the second question. The second question of the day is, the first was to figure out whether the ith bit is set or not. The second question says, set the ith bit. So it tries to say कि भाई पता नहीं करना मेरे को, मैं ऑर्डर दे रहा हूँ, मेरे को ith bit set चाहिए, करके दे दो, ठीक है? So the second question is, set the ith bit. So basically you want to make the ith bit as 1. Is the question clear to everybody? I hope it is. So now let's say if your n was, let's say 8. 8 essentially means 1 0 0 0, right? Now if somebody says that hey man, I want to set the second least significant bit, which means I want to make this bit as 1. What should I do, guys? What should I do? Do you think if I just OR my number with 0 0 1 0, I should get my answer? So what I am saying is, if you just OR your number with the second bit from the right being set, you will get the answer that you wanted. Is everybody with me? How do you arrive at this number? You could have just done 2 power k minus 1, or what else you could have done? You could have left shifted your 1 k minus 1 times. Is everybody with me? So what your answer will look like, you could have said n or, so a bitwise or, n or 2 power k minus 1, or your answer could have looked like n bitwise or 1 left shift by k minus 1 times. Guys, is that clear? So if you do any one of them, your answer will essentially become that you have set your ith bit. Okay. Guys, is everybody able to appreciate this? Is there anybody in the class who is feeling left behind? Nobody, right? I hope everybody is able to appreciate this. Cool. Now let me give you a question for homework. Abhi, I've just defined how do we do set the ith bit. Now the question for homework will be that you want to ensure that you unset the ith bit. Guys, is the question clear? So if your number essentially was, let's say 10, which will essentially means 1010. If somebody says I want to unset the second bit from the left, your number should now start becoming 8. So this is a question for homework. How do you unset the kth bit from the right? Can you guys do that? Can I give you that as a homework? I hope you guys can solve that. Cool. Now let's move on to the fourth question of the day. And I will also add a bookmark here. The fourth question of the day is find the number of set bits. Okay. So the fourth question is as follows. You are again given a number. Okay. You are given a number n. You want to find the number of set bits. Okay. So let's say your number that is given to you is something like 011 001. Can anybody tell me what this number is? This is 1 plus 0 plus 0 plus 8 plus 16. This number is 25. So if the number that is given to you is 25 and you want to figure out the number of set bits that are there, how can you do that? Guys, is the question clear? Is the question clear? The question is clear, right? So how can you do that? So you will essentially have to take a loop. How many of you understand this? Because you will have to check for each and every bit. So you will essentially need to have a loop where your loop will essentially go on till the number of bits that you had in the array. Okay. So you will have a loop and now you will just have to just try to look at it, right? If I have this number and I add this number by a 1, do you think I will understand whether my rightmost bit is set or not? How many of you understand this? If I take a AND with 1, I will understand if my rightmost bit is set to 1 or not. If I can repeat this every time, and before repeating, if I can just right shift my number 1 by 1, do you appreciate I will be able to do it for every bit? I hope this makes sense, right? So what will you do? You will just say while. I will just fill the condition of this while very soon. You will just check if your n ampersand or bitwise and 1 is not equal to 0. It essentially means that your count should be incremented by 1 because you have found a set bit at the end, right? Else you will not do anything. And after your if condition, inside the loop, you will just say n is equal to right shift my n by 1 and you will keep on repeating this. How many of you guys understand this? As your loop ends, you will just return or print the count that you have aggregated. Now, till what point do I continue this? Either I run this loop for 32 or 64 times based on what kind of a data structure I have, or I can just say while n is greater than 0. Why can I say that? I can say that because the moment my number becomes 0, then no matter how many times I right shift it, it will never give me a set bit. How many of you understand this, guys? How many of you understand this? The moment my number becomes 0, it will never be able to give me a set bit. So this will work. Is everybody in the class with me that this will work? Is everybody in the class with me? Everybody in the class is with me. Now let me give you a question here for homework. The question is that the interviewer now says that, hey man, I don't want you to destroy your number n. Do you understand, in this process I have destroyed my number n? I have destroyed my number n because at every step I am essentially changing my number. Now if the interviewer says that, hey man, I don't want to destroy a number, one option that comes to mind is I will take a temp number and destroy that. You don't want me to destroy your number, I will take a copy of it and destroy that, right? That's one way. But then the interviewer will say that, no, that's not what I wanted. I don't even want you to take a extra number also that you can destroy. So what essentially you will do? You can essentially say that rather than bit shifting my n, I will keep on bit shifting my 1. Isn't that correct, guys? Rather than bit shifting my n, I can keep on bit shifting my 1 towards the left. I was bit shifting my n towards the right. I could have bit shifted my n towards the left and I can still get the same answer. Is everybody in the class with me? Is everybody in the class with me? Cool. We have discussed very simple questions. Now let's essentially jump into some very, very interesting questions. Before I jump into that, is everybody, let me have a very quick poll so that I can understand what this class wants and tweak my way of teaching accordingly. Let me just add this. Okay. So you will have the poll on your screens now. Please let me know, guys, what do you feel about the class speed, and do it quickly. Okay, so 82% of you say that class speed is fine. 12% of you say that, hey man, I almost slept. Okay, पहले सोए नहीं थे क्या दिन में या कल लेट सोए थे? And 6% of you say that no, why are you running so fast? I can't catch up. So guys, don't worry. We have discussed very simple questions till now. Now we are going to discuss interesting questions, and the folks who are finding it too slow will start appreciating the questions now and will be happy now. And the folks who are finding it too fast, I will be spending more time on these questions, so you don't worry. So the first question of the first interesting question of today's class is that you are given, let me first write it and then I will add the bookmark. This is a question that has been asked in Google. This is a question that has been asked in Amazon. This has been a question that has been asked at DirectEye and so many other companies today. The question is, you are given an array where every number exists twice, but only one number exists only once. Okay, so what the question is, given an array, every number barring one number exists in pairs. Okay, so your question can look like 1 2 1 2 3 4 3. Can you tell me what the answer here will be? The answer here will be 4, right? Because 4 is the only number that does not exist in pairs. Every other number exists in pairs. Is everybody with me? Is everybody with me? Your answer is to find that number. Now, a lot of you are saying that I can XOR all the numbers. Isn't that the case? A lot of you are saying that I can XOR all the numbers. How many of you realize that if we had not taken this class, you would have not arrived at this XOR automatically? How many of you appreciate this? This question is not a straightforward question. Unless and until you know bit manipulation properly, you would not have been able to arrive at this number automatically. Some of you are doing a thumbs down, which means you would have already arrived at it, but that essentially means that you have studied bit manipulation before and nothing else. Isn't that correct, guys? So this question becomes very simple if you know bit manipulation, becomes very tricky if you don't know bit manipulation. So let's first of all try to look at the brute force approach. The brute force approach here would be that I can sort the array, and then every number that exists in pairs will come together. I can traverse the array and find the number that does not have a pair. How many of you understand this? The brute force solution here could have been that you sort. So solution 1 is you sort plus traverse. This solution will take order n log n. Is everybody with me? That's the first solution that comes to anybody's mind. The second solution that comes to anybody's mind is that, hey man, I can use a map and I can create a map for every number and keep the count as value. At the end, I will know what number only had one count. Isn't that correct, guys? The other option was that you take a map. But you will appreciate that in map, your time complexity becomes order n. But this time, sadly, your space complexity also becomes order n. So using the map approach, you will improve your time complexity, but you will destroy your space complexity. How many of you understand this, guys? So in an interview, the interviewer may say that, hey man, I can't compromise on time, which you are doing in solution 1. I can't compromise on space, which you are doing in solution 2. Then you will get stuck. But if you know bit manipulation, you will say, hey man, bitwise XOR has this beautiful property where if you XOR the same number with itself, the exclusivity gets lost and the number starts to contribute 0. Isn't that the case? The moment you see your number again in the XOR operations, the exclusivity is lost and their contribution becomes 0. So why not I XOR all the numbers, and all the numbers that existed in pairs will become 0, and my answer will essentially be the answer that I was looking for. How many of you appreciate this, guys? This will only take order n time, and this will take order 1 space. So this is the best solution that you can come up with for this question. Will everybody remember this always? This is the first question from bit manipulation where you could have solved a question from these tier 1 companies very, very easily if you know bit manipulation. Let me give another question. First of all, let me add a bookmark here, which was to find the number that exists only once. Okay, this is the first question that I discussed. The fourth question. Now the fifth question is essentially a question that I saw being asked at direct time very, very recently, and that's a slightly more interesting question. Let's try to look at this question. All the numbers that you had, you are again given an array of size n, but all the numbers that you had exist in pairs, but this time around 2 numbers exist only once. How many of you appreciate the question? That in the previous question there was only 1 number that exists only once. In this question there are 2 numbers that exist only once, and you want to find both these numbers. So let me give you an example. Let's say A was 1, 1, 2, 3, 5, 3, 2, 7, 8, 8, and let's say 9 was the first number and 9 is the last number. Do you know all these numbers exist in pairs barring 5 and 7? Does everybody appreciate this? Only 5 and 7 are the numbers that don't have pairs. Every other number has a pair. So this question will want you to return 5 and 7. Is the question clear to everybody? Now, maybe a lot of you would not have seen this question. Now I don't see these very jumpy people who are giving answers very quickly. But this is where actual learning will happen. Okay. First of all, in this question, how many of you think that I could have done this by sorting? Is everybody with me? Okay, Milind, I will repeat the question. Everybody, please pay attention. I am repeating the question once again. Milind, this question is exactly the same as the last question. But in this question, I have two numbers that exist only once. Milind, does it make sense? Every other number barring two numbers exist in pairs, but there are two numbers that exist only once, and you need to figure out both these numbers. Milind, is the question now clear? I hope the question is clear. I will also add a bookmark here. Find the numbers that exist only once. Find the two numbers that exist only once. Anup, you're absolutely right. Anup, that's a wonderful approach. You're absolutely bang on target. Anup, have you seen this question before? Have you seen this question before? You have? Waiting for a reply, man. I can't see who did this upvote. If you have seen this question before, that's great. But if you have not seen this question and you have solved this right now, that's even more great. Okay. So if you have solved this for the first time here, that's superb. Cool. So now, everybody, please pay attention. I want to figure out two numbers that do not exist in pairs. Do you appreciate that I could have solved this question by sorting? How many of you appreciate this? That I could have sorted. My solution one will look like sort all the numbers and then do a traversal. This will take me order n log n time, and I will be able to solve this. Is this clear to everybody? This is one approach, but this is not that great because it is in n log n time. The other approach, again, hash map will work here, but again the same problem, that your space complexity becomes order n, and that's not what I want. Now, for the third solution, how many of you understand that, hey man, I can hope to solve this using bit manipulation? How many of you have this idea? How many of you have this idea that, hey man, I can hope to solve this using bit manipulation? Okay. Yes, that's good. Now, I want to make a claim. Okay. I want to make a claim. Let's try to look at all the numbers. Okay. Let's try to look at all the numbers in their binary representation. Okay. Is everybody with me? Is everybody with me? Let's try to look at all the numbers in its binary representation. Okay. So let's say my first number was 9. So 9 will be represented as 1001. Second number is 1. It will be represented as 0001. Third number was again 1, represented as 0001. Fourth was 2, represented as 0010. Fifth was 3, represented as 0011. Then I had 5, represented as what? 0101. Then I had 3, represented again as 011. I had 2, represented as 0010. I had 7, represented as 0111. Then I had 8, represented as 0100. I had 8, represented as 0100. Then I had a 9, represented as 1001. Is everybody with me? Or did I make a mistake? Oh, sorry. 8 is not this. 8 should be 1000. Any other mistake, guys, that I did? I hope no other mistake, right? Cool. So now I have these numbers. One more 8. Okay, there was one more 8. I made a mistake in both the 8s. That's great. Okay, so I've solved that also. Now, we have seen this. I can of course, XOR all these numbers. Isn't that correct? If I XOR all these numbers, do you understand all the numbers that were existing in pairs will cancel each other out? So if I XOR all these numbers, do you appreciate that my answer that will remain will essentially be the XOR of the two numbers that don't have pairs? So if I XOR all the numbers, my answer will be 5 XOR 7. Right? Is everybody with me? So just because I have a lot of numbers existing in pairs, the first thing that comes to my mind is, why don't I XOR the numbers? How many of you will also have this thing coming to your minds the first time? Just because you have lots of numbers existing in pairs, why don't you XOR them and cancel all the numbers in pairs? And now you're only left with two numbers, 5 or XOR 7. But the problem is that the question, the input is, interviewer is asking you to give both the numbers. My question to you is, 5 essentially basically means 0, 1, 0, 1. And 7 basically means 0, 1, 1, 1. If you XOR both of them, you will essentially get 0, 1, 0, 0. This is nothing but 2. So your XOR will give you the number 2. From this 2, you somehow need to figure out 5 and 7. How many of you appreciate this? Your question has boiled down to a simpler question, which says, from 2, can you somehow take me to 5 and 7? Is this clear to everybody? This is. But don't you think that this problem itself is very tough? How can you take two numbers from one number? How can you deduce two numbers from one number? That's not that easy. How many of you understand this, guys? How many of you understand this? A lot of you do, right? Cool. Now, I have a question for you. I have essentially looked at my XOR. Looking at my XOR, do you appreciate this? One tells me a lot about my two numbers. If I look at the XOR and look at any set bit in my XORed value, that set bit gives me great amount of information. Isn't that correct? Because this one tells me that out of the two numbers, one of them will have a 0 at that index and the other will have a 1 at that index. How many of you appreciate this, guys? The wonderful property of XOR. And that's why, guys, I explained that multiple times at the beginning. I always said, XOR mein hamesha yaad rakho exclusivity. XOR is wonderful because it gives you exclusivity. XOR being 1 means that exactly one of them needs to be 1 and exactly one of them needs to be 0. Right? So just because if you look at any of the ones in the XOR number, it tells you great amount of information that one of the answer had a 1 at that digit and the other answer had a 0 at that bit. How many of you appreciate this, guys? So I know that at the second least significant bit, one answer will have a 0, the other answer will have a 1. Now my question to you guys is, can I say this in a generic format? By that I mean, for any possible input, will I always have a scenario where I have at least one in the XORed answer? Guys, do you understand my question? No matter what your input was, can you make a claim that no matter whatever my input was, I will always have at least one set bit in the XORed result? How many of you understand this, guys? How many of you understand this? The answer is yes. You can always say that because any two numbers which are different from each other, they must have at least one set bit in XOR. Can I make that claim, guys? Because if there was no set bit, it essentially means that all the bits were exactly the same. And if all the bits were exactly the same, A and B could not have been two numbers. So I have proved that no matter whatever two numbers those are that are remaining, they will always have at least one set bit. How many of you appreciate this, guys? How many of you appreciate this? I have just proven that there will be, no matter what the numbers are, there will be at least one set bit for you. Now, I have got a wonderful hold that one of the answers will have a set bit, the other answer will have an unset bit. Ankit, you're absolutely right. Using this, can I divide my input in two different sets? Using this, can I divide my input into two different sets? One set having the numbers which had set bit in the second last, and the other set having the number 0 in the second last bit. How many of you understand this, guys? I know that my A will belong to a set where it has 1 at the second least significant bit. B will belong from a set where it has 0 from the second least significant bit. Why don't I divide my input numbers to figure out at least prospective sets? How many of you are with me? So what will I do? I will divide my input into set A and set B. In this bit is 0. Let me move this to set A. In this bit is 0. Let me move that to set A. In this second last bit is 0. Let me move that to set A. In this second last bit is 1. I will move that to set B. Is everybody with me? Is everybody with me? In this second last bit is 1. I will move this into set B. Second last bit is 0. I will move in A. Second last bit is 1. I will move to B. Second last bit is 1. Move to B. Again move to B. Move to A. Move to A. Move to A. Is everybody with me? So now my sets will look like the following. A will have 9, 1, 1, 5, 8, 8, and 9. Guys, do you see this? Do you see this? A will have this. What will B have? B will have 2, 3, 2, 7. That's it. It will have 2 3s, right? It will have 2 3s because this is in set B. This also is in set B. Then I will have a 2, I will have a 7, and I will have another 2. So this will be my set B. Is everybody with me till this point in time? I have divided my input into two sets. One set having the numbers which had 1 at that kth bit. The other set having numbers which had 0 at the kth bit. Now, do we know that one of my answers will lie in set A and the others will lie in set B? How many of you understand this? Now, do you appreciate that apart from that number, that is what I'm looking for, all the numbers in set A will exist in pairs? Can you guys appreciate this? Apart from the number that I was looking for, all the numbers will exist in pairs. I can make the same claim in set B as well. Apart from the number that I was looking, all the numbers will exist in pairs. How can I make this claim? I can make this claim because my question was saying I have all the numbers existing in pairs, only 2 numbers are not existing in pairs. I know that those 2 numbers are now put into different sets. Every other number that existed in pair, they will always go to only one set. The entire pair will only go to one set. How many of you guys understand this? So now in set A, there is only one number that does not have any pair. In set B, there is only one number that does not have any pair. And now if you solve for set A using the previous question, that is XOR all of them. So let's call it XOR 1. And you solve the set B using the same previous question. You just call this XOR 2. XOR 1 will give me 5 and XOR 2 will give me 7. And I can always return my answer as XOR 1, XOR 2. How many of you guys appreciate this? Isn't this amazing? Isn't this amazing? We have just used a few observations to solve a much tougher looking question in a much simplified manner. I would want you guys to let me know how many of you have doubts. Take a minute to think about it. How many of you have any doubts? Please let me know, guys. Anchit, I will discuss that, whether it will take extra space or not. Just give me a minute, okay? How many of you appreciate this question, guys? How many of you appreciate this? Everybody does. Isn't this amazing? Now, Shashi has a question. Shashi says, what if the two numbers that you had, Arun, I will come to space in a moment. I will come to the space in a moment. But does this logic make sense to you, Arun? Shashi has a good question. Shashi says, what if in the XOR, you did not have only one set bit, but you had multiple set bits? Shashi says, what if I had multiple set bits? Guys, my question to you is, can you use any of the two set bits? Does it really matter what set bit am I using to do my division? I could have done my division on any of the set bits, because all the set bits tell you an information that, hey man, one of the two numbers will have a set bit here, the other will have a unset bit here. Is that correct, guys? Is that correct? Is that correct? So you could use any of the set bits without any issue. Okay, that's great. Is the logic clear to everybody? I will just discuss that space in a moment. Is the logic clear to everybody? I would want all of you to reply, man. Please, guys, all of you, please reply, because this is an interesting question. I would just want to understand if the logic is clear to all of you. Okay, I have only got half of the class replying. What about the other half? मन नहीं कर रहा एक क्लिक करने का. Abhay has raised his hand. Let me unmute Abhay. Hey Abhay. Hey Abhay.
Hello. Hello.
Yeah, hi.
Yeah, hi Tarun. Am I audible now?
Yes, you are audible.
Yeah, I have a question. Actually, for dividing this whole array into two sets, can we do bitwise AND with every number, bitwise AND of the XORed obtained with every number to distribute it to different sets, and then XORing every number in one set in the same iteration? I mean, is it possible?
Are you saying can you do that in order n time? Is that your question?
Yeah, setting in, distributing in different sets and simultaneously obtaining the XORs. I mean, we can do that, I think.
Right. So let me just give me a minute, and let me define the algorithm, not only to you but everybody in the class, and you yourself see whether it will take order and time, and it will also answer all the questions that are there for space. Okay. So I will just maybe there is some disturbance coming from your end. I will just mute you, and I will unmute you once again once I have explained the algorithm, and then you can ask your questions again. Okay.
Okay, fine.
Yeah. Okay, guys. So please pay attention. Everybody, please pay attention. First of all, yes, until you're absolutely right. Let's look at the step 0. In step 0, if I find the XOR of all numbers, is that possible? Will that take me order n time and order 1 space if I wanted to find XOR of all the numbers? Arjit says my voice is muffled. Is that true for everybody else? Okay. My voice is not clear, guys? Is my voice not clear? Okay, it's not clear. Okay. Let me join again. Don't go anywhere. Let me join again. Is my voice better now, guys? Is my voice better now? It is better now. That's great. Let me reshare my screen. Just give me a minute. Okay. Is my screen also visible? It is visible. That's great. Cool. So let's look at this. In my step 0, can I just do a XOR in order n time and order 1 space? I can do that. Isn't that correct? Okay. Now, in step 1, can I find any one bit which has a 1 in my XOR? Can I find any one bit which has a 1 in my XOR? How can I do that? So I will just, in step 1, I want to find the K. In step 0, I wanted to find the XOR. In step 1, I want to find the K. How will I do that? I will start taking AND of my XOR with 1, right? The moment I get my answer as my the moment I get my answer to be 1, or let's say greater than 0, I will understand that, hey man, this bit is a 1. And after every check, if this was not greater than 0, I will keep on left shifting my 1. Is that correct, guys? I will keep on left shifting my 1. So I will basically say, just try to find out 1K where XOR of 1 left shifted K times is greater than 0. Guys, is that clear to everybody? This will also take me order 1 space, right? And this will take me order K time, which is essentially nothing but order of 32 or 64. Is that clear, guys? Abhi tak I have done 2 steps. I have not taken any extra space. I now not only have the XOR, but I also have the K, any 1K where the XOR value was 1, which means out of A and B, one of them had a 1, the other one had a 0. I have got all of that now. What do I need to do now? I essentially need to traverse over my array now. So what will I do? I will say for I from 0 to n minus 1, that is, I'm traversing my array. I can just say if the answer, so what do I want to say? I want to check if the kth bit is a 1 or a 0. Isn't that correct, guys? So what can I do? I can say if array of I and 1 left shifted K times is greater than 0. How many of you appreciate this, guys? This will tell me if the kth bit in the ith number is 1. If the kth bit in the ith number is 1, do you appreciate I need to update my XOR 1? My XOR 1 becomes XOR 1 XOR AI. Else, I have a situation where the ith number ki kth bit is 0. I essentially need to update my XOR 2. How many of you understand this, guys? After doing all of this, I can simply return a pair of XOR 1 and XOR 2. How many of you understand it is taking no extra space? It is taking order 1 space and it is taking order n time. And that is what I wanted to do. Is that clear to everybody in the class? Anybody has any doubt, please raise your hand. I will explain that once again. I will very quickly explain that once again anyhow. The first step is find the XOR of the entire array. That will not take any extra space. You get the XOR of the entire array. The second step is find any bit K where the XOR was 1. And my claim is no matter whatever input you have, you will always have at least one bit with the XOR 1. Because if all the bits of the XOR value was 0, it will mean that A and B are same. Is everybody with me? Because all the bits of XOR will only be 0 if both A and B were same. And that we know is not the case because the question tells us there are two numbers which don't have any pairs. So there will at least be one bit where I have the XOR value as 1. I just need to find any one of that bit. Let's assume I have found that bit as K. Okay. After I found my bit as K, I just need to iterate over all the numbers and check for every number whether the kth bit is a 1 or a 0. How many of you understand this, guys? If the kth bit is a 1, you put that in group A. If the kth bit is a 0, you put that in group B. But to be honest, I don't really want to know the numbers. I only want to XOR them in different groups. So rather than putting them in separate containers, why don't I just update my XOR1 and XOR2, and at the end I can just print or return my XOR1 and XOR2, and in no extra space, in order and time, I have my solution. Is everybody clear now that it's a wonderful approach? And how will you arrive at this approach yourself? I've also answered that. So you will always be able to solve questions by drawing observations. What are the observations here? The first observation here is, hey man, I want to look at two numbers that don't have any pair. The moment you hear about pairs, XOR should come to your mind. Is that clear, guys? Because XOR will cancel out all the pairs. Now that's one observation. The second observation is, on XOR, Ishan says initial value of XOR1 and XOR2 is 0. Yes, Ishan, you will start your XOR and your XOR1 and your XOR2 all with 0, because XOR has a great property that the moment you take 0 as XOR something, it gives you the answer. So the identity is 0, so yes, you will initialize them with 0. So the second observation here, guys, was that I am not getting the answer by doing XOR, but I am getting A XOR B, where A comma B is my answer. Is everybody with me? The second observation was that I want to figure out A comma B, but I am getting A XOR B. Right? Now I want to figure out what those two numbers are. This problem itself looks very complicated, that how can I get two numbers from a single number? But if I again dig deeper into the properties of XOR, you will realize that the set bit of a XORed value is very significant. How many of you appreciate this? The set bit of a XORed value gives you a lot of information. Why? Because that tells you that, hey man, I am talking about exclusivity. If the set bit is 1, it means one of them will be 0, the other one will be 1. I'm talking about exclusivity. Using this exclusivity, can I divide my input into two halves? One group saying that, hey man, I have 1 at the kth bit, and the other group saying I have 0 at the kth bit. I will be able to segregate my answer into two spaces. How many of you appreciate this? I'll be able to segregate my input into two spaces. And I have this wonderful property that one of my answers will lie in group 1, the other answers will lie in group 2, and just because in the entire array only 2 elements were single, every other element exists in pairs, both the groups apart from the answer will be filled with pairs. And that's a problem that we can solve very easily, because removing pairs only takes us to do one XOR. Why don't I XOR both group A and group B? I will get the answer that I wanted. Guys, do you appreciate what are the step-by-step observations that you can use to solve this question? I hope you guys do. This is a wonderful question that has been asked in DirectType. I can guarantee you that this will be asked in companies like Google, Amazon, or Microsoft. This is a question that will come in very, very handy in any of your company interviews. Okay, so we have answered this as well. Now, let's move to the 6th question of the day. Guys, can we move ahead? Is everybody with me? Can we move ahead? Cool. So it's 10:47. I have time till 11:30. I would want to cover 2 more questions. And so just remain with me. Okay. So the 6th question of the day is the following. You are given an array. You want to find the pair with the minimum XOR. So let me just add the bookmark and then I will explain that. Pair with the minimum XOR. So let's look at it. Let's take any array. Let's take your array was 1, 4, 5, 2, 3. Okay. Let's assume this was your array. Now, I want you to tell me the pair with the minimum XOR. Is the question clear to all of you? This question has been asked in Microsoft. This question has been asked in Paytm. I have seen this question being asked in Adobe, and I've seen this question being asked in Amazon. So it's a reasonably good question. The question is, you want to figure out the pair with the minimum XOR. Minimum value, the minimum XOR value. So in this case, so first of all, the brute force is, why don't I try all the pairs? Isn't that correct, guys? The brute force is, why don't I try all the pairs and look at the XOR value of all the pairs? So 1 XOR 4, what? So let me just very quickly write these numbers. 1 will be 0001, 4 will be 10100, 5 will be 0101, 2 will be 0010, and 3 will be 0011. Is that correct, guys? Right. If there are multiple pairs, you just need to print any one of them. If there are multiple pairs with the same, you can just need to print one of them. Now Soumitra asks a question: are all the pairs distinct? Soumitra, the question does not claim that, but I have a question for all of you now. If there is any pair, if there is any number which is repeated, do you know the answer to this question already? If there is any number that is repeated, the answer to this question becomes 0 already, right? So that's a great observation. The first observation that you should make is, the moment I have a repeated number, my answer becomes 0. So that's observation 0, but that only tackles to some problems. In a lot more other problems, you will not have any repeated number, right? But yes, for some segment, you have already answered it. The moment you have a repeated number, your answer becomes 0. That's great. Now I want to figure out for all pairs. So one way is a n-square approach, where you take pairs of all the possible pairs that you can find, do their XOR, and see the minimum number, right? So that's one approach. Is everybody clear with that approach? Okay. Now guys, that will take order n squared time. I want you to reduce your time complexity. I would want all of you to give it some thought. How will you do this? How will you do this? Shadab, that's a great observation. Anoop, that's a great solution, man. That's absolutely correct. Himanshu, you have a great observation. Shashi, I don't think so. Anchit, I did not understand your comment. Is that a question? Is that a comment? I did not understand it properly. Soumitra, you're absolutely right. Abhay, you have a wonderful observation. Anchit, you are absolutely right. Keshav, you are absolutely right. Chirag, you are on the right track. Prasoon, you are absolutely right. So I am very, very happy that a lot of you are able to come to the solution, and that's a great thing, because that essentially means that you've understood the concept well. Cool. So let me now try to tell you how I will build observations for the same. Should I do that, guys? Should we do it observation on observation? How do we solve this? If this was a new question that we are seeing for the first time, the first observation that somebody, Soumitra, if I remember your name correctly, Soumitra, it was you who told us that the first observation is, if you have repeated numbers, my answer is 0, right? And essentially any of the repeated pair I can output, my answer will be 0. Isn't that correct, guys? Isn't that correct? So you essentially, your answer will be 0 in this case. Now, the observation 1 that I would want to make is the following. The XOR, if I don't have any repeated numbers, because if I had repeated numbers, I've already solved for it. The only thing that I'm now remaining to be solved is, what if I did not have any repeated number? If I don't have any repeated number, how many of you understand that the XOR value will have at least one set bit? Again, the same thing that we observed in the previous question. If the numbers are different, the XOR value will have at least one set bit. Is everybody with me? Is everybody with me? This is the second observation. This is again a very, very critical observation in this question. And again, this is great because XOR tells us about exclusivity. Observation 2, right? If I know that there is at least one bit which is a set bit and I want to minimize my XOR, how many of you understand I need to find the set bit that is rightmost, as right as possible? How many of you appreciate this? I know there will be at least one set bit. My question is, why don't I look for set bits that are, the first set bit should be as right as possible? Because the earlier you get a set bit, the bigger your number becomes. How many of you appreciate this? This is again a very, very powerful observation, that your first set bit should be as right as possible. Guys, isn't that correct? This is the observation 2. Now, if I don't want set bits to occur very first in the answer, do you appreciate that numbers that are closer to each other have lesser probability of giving the most significant bit as 1? Let me just write it and then I will explain this. The third observation that will come to my mind is numbers that are closer on the number line will have less probability of a set bit upfront. How many of you guys appreciate this? The numbers that are closer to each other will have the least probability of having the most significant bit different. Why do I say so? Let me try to explain that. Let's look at the number line. First of all, how many of you appreciate observation 0? Please tell me, guys. Everybody does. How many of you appreciate observation 1? Everybody does. How many of you appreciate observation 2? Everybody does. Observation 3 is something that some of you may not appreciate. Let me try to make sure that you appreciate it. Let's look at any number line. You will have a 0 here, you will have 1 here, 2 here, 3 here, you will keep on going on. Let's say you have a 10 here, you have 11 here. Let's say you have a minus. So, and forget about negative because the question says I only have positive numbers. So let's only look at the one side of the number line. And let me just cut it, bring it here so that I can add more numbers, right? So let's say you have the number line extends, you have somewhere 20, 21, 22, then you have 40, you have 41 and so on and so forth. Do you appreciate that your numbers will start with 0, 0, 0, 0? As you move one number ahead, your most significant bit does not change. How many of you appreciate this? As you move on, the numbers only start changing from the right. Then you move on to 2. Nothing gets done to your most significant bit. It becomes 2. Then you move to 3. Nothing gets done to your most significant bit. You make it 3, right? Because the idea is that the most significant bit will only change once you cross another power of 2. Is that correct, guys? Is that correct? So this second last bit has changed when you crossed this power of 2. 4 may, this is the second power of 2. The third last bit will change for the first time. 8 may, the fourth last bit will be changing for the first time. 16 may, the fifth largest bit will be changing for the first time. Guys, are you there with me? And so on and so forth. 32 may, the sixth largest bit will change for the first time, and so on and so forth. So you see that the bits that are most significant only change as you move along in the number line, and numbers that are together to each other have the tendency of having same most significant bits. Is everybody with me? Is everybody with me? Right. So the idea is that the most significant bit only changes once you cross a particular threshold, and once you have crossed that threshold, that number never changes. Is that also correct, guys? So the moment you have crossed, let's say 8, this bit will always remain 1. Isn't that correct? No. Just think about it again. फिर से. This bit, will it all remain 1? It will not. It will not always remain 1, because the moment this becomes 1, there is no need for it to be remain 1. But the idea is, the moment this becomes 1, your pairwise XOR will become even bigger. How many of you appreciate this? Your pairwise XOR will become even bigger because you essentially had even a more significant bit being 1. So I hope you guys have some intuition that why numbers that are closer to each other have a higher probability of giving a first set bit on the right in your XOR. So if guys, is this observation clear? Is the observation clear? I will just make even a stronger claim, and then we will get to this answer very quickly. But if this observation is clear, that will allow me to make even a stronger claim in just a minute. The fourth observation says, and it's more of a claim, that if you want to minimize the XOR of A comma B, A and B should be consecutive in your array. What does this claim say? This claim says that, hey man, forget about any other pair, only look at the adjacent pairs. How many of you appreciate this, guys? This claim essentially in normal English language means only look at adjacent pairs. What does it mean? It means, so let's look at our input once again. Our input was 1, 4, 5, 2, 3. It means that 2 can hope to give you the least XOR only with 3 or with 1. Does everybody appreciate this? Adil, you're right. I essentially don't want to say adjacent pairs without the sorted array. I want to say adjacent pair in the sorted array. Right? Adjacent in with respect to the number line. Adil, does it make sense? Adjacent with respect to the number line. So what I essentially want to say here is, if 2 was to give my minimum XOR, it can only give with 3 or 1. Similarly, if 5 was to give my minimum XOR, it can only give with 4 or 6, 7, 8, but there is no number greater than 5. So it can only give with 4. Similarly, if 3 had to give me the minimum XOR, it can only give with 2 or it can give with 4. How many of you appreciate this observation, this claim? That you only need to look at adjacent pairs in the sorted array and not all the pairs. So if I just sorted my A, if I changed my A to A dashed and just sorted it, now the number of pairs that I need to evaluate is order n. I was getting an order n square time complexity because I was evaluating all the pairs and there was n square different pairs. In this question, I will only evaluate order n pairs because I am making a claim that only numbers that are together in the number line can give you a minimum XOR. How many of you appreciate this? If you want, I can prove this claim mathematically also, and that will be very interesting to see. But intuitively, is this clear, guys? Intuitively, is this clear? I can give you this claim mathematically also, but I hope intuitively this is clear. Right? Intuitively this is clear. Now, how many do you want me to give the mathematical proof, guys? Okay. So let's try to, and essentially we should in every class try to do some mathematical proofs or at least one mathematical proof every week, so that we improve our tendency and improve our way of approaching things mathematically, right? And that is something that will help us a lot in the long term. So let me try to tell you how will I try to mathematically prove it. My claim is that A can give the minimum XOR only with a number B such that there is no number C in between them. Is that clear, guys? My claim is A will give minimum XOR only with adjacent numbers in sorted array. Guys, isn't this my claim? Isn't this my claim? Right, this is my claim. So let me try and start with my claim. I will say that, okay, A is a number. It will have some bits. Okay, A is a number, it will have some bits. B is also a number. It will also have some bits. Is that clear? A is a number, it will have some bits. B is a number, it will have some bits. Now, without loss of generality, let's assume my A is less than B. What do I mean by without loss of generality? Without loss of generality is a phrase that you use when you want to assume something and you are saying that, hey man, this is not a specific case. For any case, I could have done this. So I am saying without loss of generality, let's assume A was less than B. Now some of you will say that, hey man, what if A was greater than B? I will say just switch them. You will always have a scenario where one number is smaller than the other number. Is that correct, guys? Is that correct? Is that correct? So I can say without loss of generality, let's assume A is smaller than B. Now, do you appreciate? For a lot of bits, the value in A and B will be the same because they are together. For a lot of most significant bit, the values in A and B will be same. And there will be one bit where the first time the value switches. How many of you appreciate this? For a long amount of time, the values will be same because they are adjacent. But there will be one bit where the value changes. Let's assume that is this bit. And do you appreciate A will definitely have a 0 and B will definitely have a 1? Because A is smaller than 1, B. So A will definitely have a 0 and B will definitely have a 1 because A is smaller than B. Is that clear to everybody in the class? A will always have a 0, B will always have a 1 because A is smaller than B. And this is the first bit where the change is happening. That's great. I am now making a claim that let's try to prove this with contradiction. So I will say, no, my claim is false. It cannot be a case where my claim is false that A can still give me the minimum XOR with a number other than B. How many of you appreciate this? If I want to prove this by way of contradiction, I will make a claim that no, I am not satisfied with this claim. I can give you a new number. Let's call that number X, which is not between A and B, because that is what your claim says. Your claim says you are only going to look at adjacent numbers in your array, in your sorted array. I said, no, I have a number X that is not between A and B, which will give me a smaller XOR with A. How many of you appreciate this? If I try to prove this and realize this is not possible, I will make a proof that A can only give minimum XOR with B. Guys, samajh aa raha hai? Kuch samajh aa raha hai? So what I'm trying to do here, I have a claim that A can only give the minimum XOR with the near numbers, with the adjacent numbers. I am saying that no, let me try to disprove this. So I will try to prove my initial hypothesis by way of contradiction. I will say no, there is a X which is not between A and B, but A will give the minimum XOR with X. Okay, let's try to do that. If A needs to give minimum XOR with X, how many of you appreciate in the X as well, all the bits that were same in A and B need to be same in X as well? How many of you appreciate this? Because if a bit which was same in A and B is not same in X, it will essentially mean that X will give you a larger XOR. Isn't that correct? Because if my XOR needs to be small, my first change bit needs to be as right as possible. So if X needs to hope to give me a smaller XOR, it can never make a change in all the first common bits. Is this clear to everybody? It will never give a change in the first common bits. Now we reach to the bit where the change happened. 0 and 1. If X needs to be the number that gives me the smallest XOR, but X is not the closest number to B, do you appreciate that my X will only be 1. Do you appreciate that? Because if my x is farther from b, and if b had a 1, will my x also have a 1? How many of you appreciate this, guys? If my b had a 1 and x was even farther than that, right? And x did not have a 1 previously, but x is still a greater number than b, then this must be 1. How many of you appreciate this? How many of you appreciate this? Everybody does. Cool. So when I was comparing a with b, this was the first change that happened. When I'm comparing a with x, this is again the first change that happened. Have I improved my answer yet? Have I improved my answer yet? I have not. I will not be able to improve my answer anywhere down the line also, because my x was greater than my b, which essentially means that it will only change. Try to appreciate it, guys. Try to appreciate it. Let me just wait for a minute. Nikita, do you want to be unmuted? Do you want me to unmute you and maybe let you share your example? Because this line, I'm not able to appreciate what you're trying to say. If you want me to unmute you, I will be happily after this one. Cool, that's good. So now, guys, appreciate. My x, right? My x will never be able to have a 0 here, because if it had a 0 here, hoping to give me a smaller XOR, my x would have been between a and b. How many of you appreciate this, guys? So in a way, I have proven by way of contradiction that my x, if it happens to be after b, will not be able to give me a smaller XOR. Guys, is that correct? I have just found a contradiction to what I assumed, and I've proved that that is not possible. So I have mathematically proved what we were able to see intuitively. I have now mathematically proved that numbers that are next to each other can give you minimum XOR. Is this clear to everybody in the class? I want all of you to reply. Even if the mathematical definition is not clear, that's fine. But is it clear intuitively? It is, I'm hoping. So what will we do? We will essentially sort my A, and in the sorted A, I will only compare adjacent pairs, which will mean order n pairs. And out of those order n pairs, whatever gives me the minimum XOR, I will return that as the answer. Is that clear, guys? Will you be able to solve that? Now I will unmute Nikita, and Prashant, if you also want me to unmute you, I will unmute you as well. Hey Nikita, I have unmuted you. Prashant, if you want to be unmuted, please let me know. And if anybody else wants to be unmuted, please raise your hand. I will be happily unmuting you as well. So let me unmute Prashant as well. Hey Nikita. Hello. Nikita, I'm not able to hear you. Guys, are you able to hear Nikita? Nikita, I think we can hear you now. No, we can't.
Hi, Tarun.
Yeah, I can hear you, Prashant.
Yeah, XOR of 7 and 8 gives me 15.
Okay, so let me just write it very quickly. So I have this 8. 8 essentially means 1, 000. I have a 7, which essentially means 0, 111. Okay.
Yeah. And XOR of 7 and 10.
XOR of 7 and 10. What is 10? 10 essentially means that you will have 1,
1 0.
1 0. Okay. So now
Yeah.
XOR of 7 and 8 gives you what?
15.
It gives you 15. That's right.
Yeah.
And XOR of 7 and 10 gives you what? It will definitely give you 8. It will also give you this number, which is 4. It will also give you this number, which is what? 13.
Yeah.
Okay. How is that possible? Just give me a minute. 8 plus 4, which is 12. 12 plus nothing from here. And okay. Just give me a minute, guys. 7 is giving an even smaller XOR with 10. Then it is giving with 5 with 8. But that's not an issue, right? Why is that not an issue? Because when you have sorted this, hey Prashant, are you there? I hope you are. Hey Prashant, I'm not able to hear you, but I'm hoping you are there. You can just write if you are not able to speak. But anyhow, everybody please pay attention. So yes, that's a great claim. That 7 will give me the minimum XOR with 10. But the idea is, 7 will give me a smaller XOR with 10 as compared to it will give me with 8. But if you just look at 8 and 10, okay, if you look at this pair, do you appreciate that your XOR will essentially be only 2? Prashant, are you there? Guys, are you able to appreciate this? Please say yes if you are able to appreciate this. So yes, 7 will give you a bigger XOR with 8 than it will give you with 10. But you will still get the minimum answer by looking at the XOR of 8 and 10. So what my claim essentially is, if 8, whatever XOR 8 will give minimum with, can only be 7 or 10. Okay, first of all, how many of you got Prashant's question? Please say yes. Everybody got Prashant's question, right? Now, I have one claim here. The basis of my observation here was that if you look at any number, that number can give you the minimum XOR with its adjacent numbers. Guys, do you remember that? A number can give you XOR with its adjacent numbers. If you look at 8, 8 was 7, or 8 had a 10 on its right. Okay. Now, for any number on the left of 8 and for any number on the right of 8, the only things that really matter for me is to look at 8 and 10 and 8 and 7. Because if there was a number on the right of 8 that could have given me a smaller XOR with 8, it would have been better if I used even the numbers that are next to that. Guys, is it making sense what I'm trying to say? I am trying to say that out of all the prospective possibilities that you are seeing, you may get a possibility. You will be definitely getting a adjacent pair which will give you the minimum answer as compared to looking at farther away pairs. Is that clear? Prashant, is that clear? Is there any question? Anybody else wants to ask any question? Feel free to do that. Prashant, I'm not sure if you're still in the class or not. You are in the class, but we are not able to hear you. Do you want me to unmute you again, Prashant? If you want me to unmute you again, let me try to unmute you again and see if you have to add something here. No, you are not in the class. Prashant is not in the class, it seems. Prasoon is there in the class. Guys, is it clear to everybody? Okay. Can we move to the next question now? So essentially, you can sort your array. Look at every 2 consecutive numbers and get your answer. Okay. So let's now move to the last question of the day. We have 13 minutes, but I will be able to cover the 7th question of the day as well. The question is as follows. You want to figure out the sum of the Hamming distances. How many of you know what a Hamming distance is? Anybody has heard about the term Hamming distance? If out of all the people who have heard it, can anybody write the definition of Hamming distance on the chat? Sum of all pairs of Hamming distance. I've added the bookmark. Anybody wants to tell me the definition? So this Yes, Abhay, you are absolutely right. This question has been asked in Google. This question has been asked in Amazon, has been asked in DirectType, and a lot of other companies as well. So this is a very, very interesting question. The question is, you are given an array. So let's assume the array as 1, 3, 5. You want to tell me the sum of all pairwise Hamming distance. Okay. Now, pairwise, sum of all pairwise. So first of all, you need to look at all the pairs. So what all pairs can be here? 1, 1 can be a pair. Repeated bits are also allowed. Let's assume 1, 3 can be a pair. 1, 5 can be a pair. 3, 1 can be a pair. 3, 5 can be a 3, 3 can be a pair, and 3, 5 can be a pair. Then you can have 5, 1 as a pair, 5, 3 as a pair, and 5, 5 as a pair. Guys, do you appreciate these are the pairs that are possible if you were allowed to use the same number twice? Now, if these are the pairs that are possible, you want to look at the Hamming distance of all of them and sum them up. Now, what is the Hamming distance? Hamming distance basically says that if you represent that number in a binary format, so let's say if a number represents 1 as binary, which will be zeros and 1. If I represent 3 as binary, it will be 0, 0, 1, 1. Hamming distance says the number of bits that are different. Can you tell me what are the number of bits that are different here, guys? Between 1 and 3? There is only one bit that is different. Is that correct? So the Hamming distance between 1 and 3 will be 1. Guys, do you appreciate the definition of Hamming distance? Basically, just count the number of bits that are different. So between 1 and 1, can you tell me the Hamming distance between 1 and 1? Can anybody tell me the Hamming distance between 1 and 1? It will be 0. Between 1 and 3, what will be the Hamming distance? It will be 1. Between 1 and 5, what will be the Hamming distance, guys? Let's try to solve it. 1 is this. What is 5? 5 is nothing but 0, 1, 0, 1. So how many bits are different? Only 1. So again 1. Between 3 and 1, 1. Between 3 and 3, 0. Between 3 and 5, what is the difference between 3 and 5? You have one bit which is different here. You have another bit which is different here. So difference between 3 and 5 is 2. Then you have a 1. Yes, Saurabh, you're right. Then you have a 2. Then you have a 0. Now, can you add all of them up, guys? 0 plus 1 is 2, plus 1 is 3, plus 0 is 3, 5, 6, 8. Do you appreciate this question will give you the answer 8? Do you appreciate this question will give you the answer 8? That's great. Is the question clear to all of you? You need to find 8 in this question. Now think about it for a minute. How will you solve this question? Okay, think about it for a minute. How will you solve this question? Saurav says, what if I XOR all the numbers and find the set bits? How many of you think that will be a good idea? If I XOR all the numbers and count the set bits, will that be a good idea? That will not be a good idea, right, Saurav? Because here, let's say if you XOR all of these 3 numbers, what will the answer be? If you XOR these 2, your answer will be 0, 0, 1, 0. If you XOR this with this, your answer will be 0, 1, 1, 1, which is nothing but 7, which is not equal to your answer. So do you appreciate this will not work? And also there is no logic why you would want to do that, right? XORing all the numbers, counting set bits, that's not what we're looking for. We're looking for all the pairwise Hamming distances. You are right, Ankur, you are right. Okay. Guys, do you want to take a minute or do you want me to jump to observations? Do you want to take a minute or want to jump into the observations? Because we only have 7 minutes left. If you are fine with me trying to tell you the observations, that would be whether we can then end the class quickly. Okay. So let's move on to the observations. Okay. So let's move on to the observations. Okay. How many of you appreciate that what do I need to figure out? Let's say I want to figure out this capital H. What is this capital H? The summation of all possible i's and j's, Hamming distance between I and j. How many of you appreciate this, guys? How many of you appreciate this? This is what you want to find, the capital H. Okay. And now let's try to understand what is a Hamming distance between two numbers. It is basically just the count of different bits. Isn't that correct? Counts of different bits. So can I represent this number as summation of H dashed I j k, where k you have moved across all the bits? Can you understand this, guys? Number of different bits basically means, can you now count all the bits one by one and say ki bhai kaun si bit different hai? Can you do that, guys? Can you do that? So I could have represented this function nothing but a summation of H dashed I j k, where my k, let's say, moves from 0 to 32 if I have a number of size 32. How many of you understand this, guys? That I essentially, if I can break a Hamming distance into smaller functions, where a function will tell me whether this particular bit is different or not. And if a bit is different, it will return me 1. If a bit is same, it will return 0. If I add all of them up, I will get this Hij. So if everybody is with me, I can essentially say that my capital H is nothing but summation of all I comma j, summation of all k H I j k. How many of you understand this? I am trying to explain this mathematically. I will very quickly do this intuitively as well. But how many of you appreciate this? If you appreciate this, you will understand that this is nothing but summation of I j k H I j k. Isn't that correct, guys? Isn't that correct? I just want to figure out for every pair, for every bit, I just want to figure out how many of them were different. So let's come back now, try to look at intuitively that how will I solve this? Let's look at 1. 1 was 0, 0, 1. 3 was 0, 1, 0. And my 5 was 1, 0, 1. Do you appreciate that in all the pairs, the Hamming distance ka sum will essentially be combination of the bitwise Hamming distance ka sum? How many of you appreciate this, guys? I've just proven this mathematically, but how many of you appreciate that? Oh, sorry, 3 is 0, 1, 1. Sorry for that. How many of you appreciate that the Hamming distance contribution of this bit has nothing to do with the Hamming distance contribution of this bit? Is everybody with me? Can you guys appreciate that? So the Hamming distance contribution from one bit has nothing to do with the Hamming distance contribution from the other bit. Now let's look at it bit by bit. Let's look at the least significant bit. Do you appreciate all these numbers are the same? Do you appreciate all these numbers are the same? Does that mean that in no pair this bit will contribute anything? Because this bit is same across all the numbers, it will always contribute a 0 to my answer. Is that clear, guys? How many of you appreciate this? So I can say this bit will always contribute a 0 to my answer. Let's look at the second least significant bit. There are 2 false and there is 1 true. Guys, is everybody with me? This bit will contribute a Hamming distance of 1 if one of the bits was 1 and the other bit was 2. Is that clear? This will contribute a 1 if one of the bits was 1 and the other was 0. It means I want to fill 2 placeholders. The first placeholder must come from the false and the second placeholder must come from the true. Isn't that correct, guys? For false, I have 2 options to pick from. For true, I only have 1 option to pick from. So if I just do 2 into 1, do you appreciate this will give me the number of pairs which will contribute a 1? It will. if I just multiply this by 2 again, because I want to calculate I comma j and j comma I twice, that's why I'm multiplying it by 2 at the end. It will mean that this bit will contribute a 4 to my answer. Is everybody with me? Is everybody with me? Let's look at this bit. I have 2 false and 1 true. For Hamming distance contribution to be 1, I would want one of them to be from the false group, the other to be from the true group. From the false group, I have 2 options. From the true groups, I have 1 option. And I will just multiply this with 2 because I want to consider I comma j and j comma 1 both. That's why this bit will also contribute a 4. My overall contribution becomes 8. And this is what my answer was. How many of you appreciate this? We just piggybacked on the observation that Hamming distances, it's basically bit by bit computation. A bit will not determine or impact any other bit. Guys, does it make sense to everybody? It's 11:29. We have covered our class well in time. If anybody wants me to take another example, I can do that. Anybody in the class wants to take another example? And then I will end the class, go back, have my food and enjoy. Milind has raised his hand. Let me very quickly unmute Milind and see what he has to say. And then I will take an example and solve this for you. Hey Milind, please let me know. Hello Milind.
Are you asking for a question related to this topic or something else?
Oh yes, I'm looking for a question related to this question.
Okay. So, and I wanted to ask a question that was asked to me in an interview.
Okay.
So I was hoping to get some insight.
Right.
On that.
So maybe let's try to do that maybe in the next class. Actually, I haven't had my food. I will want to just quickly cover this and go back and have my dinner. But if you okay, so let's do one thing. Let me just complete this. In the meanwhile, you can write your question in the chat. We can either pick it today or we can either pick it in the next class. Okay.
Okay.
So, okay. Guys, everybody please pay attention. I will just take an example. And anybody wants to give me an example? Milind, do you want to give me an example for this question that I can very quickly solve?
Take 3, 4, and 7.
3, 4, 7. Maybe add one more number. Let's say 2. Okay?
Yeah, 10.
And let's say also add 10 also. Okay. 3 is nothing but 0, 1, 1. 4 is nothing but 1, 0, 0. 7 is nothing but 1, 1. 2 is nothing but 0, 1, 0. And 10 is nothing but 1, 0, 1, 0. So I will just add a 0 in front of all of them. Okay. Now I want to figure out the Hamming distance. Guys, is everybody with me? I have taken an example. Let me try to solve this very quickly. Milind, in the meanwhile, if you want to write your question very quickly, I can take it up, else we will take it up in the next class. So let's look at all these numbers, right? I want to figure out the Hamming distance pairwise. The idea is I can do it bit by bit. I will go to the least significant bit. I realize that there are 3 false and there are 2 trues. Is that correct, guys? I want to fill a pair, which means I want to fill 2 possibilities. One of them must be a 1, the other one must be a 0. Only then it will contribute to something to the Hamming distance. From the false, I have 3 options. From the 2, I have 2 options. I will multiply them 2. And this multiply this with 2 because I can compute I comma j and k, j comma 1 again. This will give me 6 into 2, which gives me 12. Is everybody with me? So the last bit will contribute 12. Let's look at the second last bit. It has 4 trues and 1 false. So my answer will look like 4 into 1 into 2, which means I will contribute a 8 here. Let's look at the third least significant bit. It has how many ones? It has 1, 1 and 3. Sorry, it has 2 ones and 3 false. 2 true and 3 false. So I will do 2 into 3 into 2, which is nothing but 12. I look at the most significant bit. It has 3 false, 1 true. I will do 3 into 1 into 2, which is nothing but 6. I will add all of them. I will get my answer. Is everybody with me? So this is how we solve it. I hope you guys, Milind, let's do that in the next class. I hope you guys enjoyed this. I enjoyed interacting with you. Hope to see you all in the next class as well. Good night. Goodbye. see you again.